Hello, everybody. Today we are covering lesson 2 from unit 8. We are going to be covering special right triangles. You can find these notes on OMHS as well as their key in the same folder where you found this recording. So there's two special types of right triangles. The first special right triangle we call a 45-45-90 triangle. And it gets its name from the angles that it has. So if you see a triangle with a 90-degree angle and two 45-degree angles, we call that a special right triangle, and we call it a 45-45-90. So in this triangle, the leg is going to be 1, and the hypotenuse will be the square root of 2. So in a special right triangle that is a 45-45-90, the sides will be in the ratio 1 to 1 to root 2. Okay. I call this the most basic special 45-45-90. And if you know the ratio of the sides, then you can take that basic 45-45-90 and compare it to any 45-45-90 because it will be similar to all 45-45-90s. That's why we learned the angle-angle similarity, remember? So if I see this special right triangle up here, if I see this special right triangle, I know that it's going to be similar to this one because they have two sets of congruent angles, which means they are similar. And if they are similar, then their sides are proportional. So if you can remember, this special right triangle will always be a leg 1, and hypotenuse root 2, then you can compare that to any 45-45-90 that you're given. I'm going to write that here, 1, 1, root 2. So when I see an example like in example 1, I like to redraw my most basic 45-45-90 right next to it. And I know that its legs are 1 and its hypotenuse is root 2. So now I can compare that to this one. X corresponds to 1 and 8 corresponds to 1. And so when you cross multiply, you get X equals 8. You didn't really have to cross multiply here since they both had a denominator of 1. It's also important to note that a 45-45-90 is isosceles, which means that its legs will always be congruent. So if you know one leg of this isosceles triangle, you will immediately know the other one. Now let's find y. Y corresponds to root 2, and 8 corresponds to 1. Now this one we have to cross multiply. Y times 1 is y. And 8 times root 2 is 8 root 2, and leave it just like that. No rounding, don't put it in your calculator, unless it tells you it wants a decimal. But most of the time it's not going to want a decimal. It just wants it in the radical form. So you would leave it 8 root 2. So let's look at number 2. I have a 45-90, which means this has to be 45. And if you're not sure, you can always use your triangle sum theorem to figure it out. 180 minus 90 minus 45. I'm going to draw that most basic 45-45-90 right next to it, and I always draw it facing the same way. So that way I can easily see that, oh, well, y will correspond to 1, and don't use x, use 25. 25 corresponds to 1, and so you could cross multiply and see that y is indeed 25. If you recognize the legs were congruent, you just immediately said y was 25, that's okay. Now x corresponds to root 2. And 25 corresponds to 1. And when we cross multiply, we get x, and 25 times root 2 is just 25 root 2. Simple as that. Let's look at number 3. I'm going to redraw my most basic 45-45-90 right next to it. And its legs are 1 and its hypotenuse is root 2. All right, so I know that x and y are going to be equal. I just don't know what either one is. Well, x corresponds to 1 and 19 corresponds to root 2. Cross multiplying here is not going to be super easy is not going to give me an answer because it's just x over 1. Right, so this really says x equals 19 over root 2. we learned way back at the beginning of the year, before we even started live classes, we did a lesson on simplifying radicals and rationalizing the denominator. And this was the reason why. So a little recap on how to rationalize a denominator. You are never allowed to leave a radical in the denominator. So because there's a root 2 in the bottom there, I can't leave my answer this way. I have to rationalize the denominator, which means I have to multiply this by 1, but not just 1. That wouldn't make any sense. It's a very special 1. Okay, so this 1 is going to have the same number in the top and the bottom, which is why I'm calling it 1. And it needs to cancel out a square root. Well, remember, a square root times a square root, or a square root squared, cancels. So I need to multiply this denominator by the square root of 2. But remember, I said this had to be 1. So I have to put the same thing in the numerator to make sure that what I'm multiplying by is actually 1. Because you can multiply any number by 1 and it doesn't change its value. Okay, so long story short, you're going to multiply by whatever's in the denominator here over top of itself. So 19 times root 2 is easy. That's 19 root 2. And square root of 2 times the square root of 2, you can think of it a couple ways. You can think of it as the square root of 4, and the square root of 4 is 2. Or you could think of it as the square root of 2 squared, and the square root and the square cancel out. Either way, you should get this nice, beautiful, isn't that a pretty answer? 19 root 2 over 2. Ooh, beautiful. Not really. But we know that the legs here have to be congruent since it's 45, 45, 90. So I don't really have to go through this process all over again for y. There could be one more step in a problem like this. If this number right here could have been divided by 2, I would have. So if it had been 18 root 2 over 2, then I would have divided that 18 by 2 and just got 9 root 2. So you might have to simplify one more step if you can simplify this fraction at all. Okay, just keep that in mind. If you need to review how to rationalize a denominator, you are welcome to refer back to any notes that you took at the beginning of the year in August. And if you don't have them, can't find them, or you want the video, just let me know and I can share that with you. I'll try to make a folder on OMHS for that also for you. Okay. There's another type of special right triangle, and this one is called a 30, 60, 90. Again, it's getting its name from the angles that are in the triangle. In a 30, 60, 90, the sides will always be in the ratio 1 to root 3 to 2. The shortest leg will be across from the smallest angle. 30 is the smallest, so the side across from that is 1. The medium side is root 3. The square root of 3 is about 1.7. You can check that if you want. So that makes it the medium side, which means it goes across from the medium angle. And 2 is the longest, so that's going to be the hypotenuse. So you make your short leg 1, your long leg root 3, and your hypotenuse 2. The short leg will always be across from the 30. The long leg will be always across from the 60, and the hypotenuse, of course, will always be across from the 90. And now I'm going to do the exact same process that I did with my 45, 45, 90. The only thing different is I'm using a different triangle. So I'm going to redraw my most basic 30, 60, 90, facing the same way that the given problem is. So that means I'm going to put a 60 down here, and the 30 would go up here. The short leg is 1, long leg root 3, hypotenuse 2. And now these two triangles are similar by angle, which means their sides are proportional. So x corresponds to root 3, and 5 corresponds to 1. Cross multiply, x equals 5 root 3, and you can leave it 5 root 3. You don't have to put it in a calculator. You don't have to use any decimals. I would prefer it if you didn't round it. This is a nice exact answer, so we're going to leave it 5 root 3. Now y corresponds to 2, and 5 corresponds to 1. Cross multiply. Oh, this is pretty. Y equals 10. All right, let's see here. In number 5, we have another 30, 60, 90. So I'm going to redraw my basic one right next to it. 30 would go here, and 60 will go here, just like it is in the original picture. The short leg is across from 30. It's 1. The long leg across from 60 is root 3. and the hypotenuse across from the 90 is 2. So now I can say x corresponds to 2 and 14 corresponds to 1. Cross multiply, we get a nice pretty 28. Y corresponds to root 3 and 14 corresponds to 1. Cross multiply and I get y equals 14 root 3. Notice I'm not using any decimals here. I'm not even using a calculator really. If you need a calculator to multiply these numbers 14 and 2 and whatever you can, but no decimals, leave it exact. Let's do the last one here, number 6. 30 will go here and 60 here, drawing it exactly facing the same way as the original problem. The short leg is 1, long leg root 3, hypotenuse 2. So x corresponds to 1 and 32 corresponds to 2. Cross multiply, I get 2x equals 32, divide by 2, I get x equals 16. If you recognized at that first step that x over 1 is just x and you just said 32 divided by 2, that's fine. Some students just really like the cross multiplying, so I went through the process for you just in case. Y corresponds to root 3 and 32 corresponds to 2. So now we cross multiply. 2y equals 32 root 3. I need y by itself, so I'm going to divide both sides by 2. So here's the case where I told you you might have to simplify a little bit more. 32 and over 2 reduces, that's 16. So that 32 over 2 is 16, and I didn't do anything with that root 3, so it has to stay here. So our answer is 16 root 3. All right, and now we've got some practice problems here. These are all 30, 60, 90s. So let's practice. I'm going to do number 7 with you, and I'll do number 8, and then I'll let you do number 9 on your own. If you really want to do them on your own, you're welcome to pause the video and try it on your own before I go over it. So in number 7, right triangle, this is a 30, 60, 90. I can tell by that 60 degrees that's right there. Short leg is 1, long leg root 3, hypotenuse 2. X corresponds to root 3 and 46 corresponds to 2. Cross multiply, 2x equals 46 root 3. I need x by itself, so I'm going to divide both sides by 2. And 46 is actually divisible by 2. 46 divided by 2 is 23. So my final answer is 23 root 3. Well, that's for x at least. And now y. Y corresponds to 1. And 46 corresponds to 2. You could cross multiply here. Or if you recognize that y over 1 is just y, well, then 46 over 2 is 23. All right, one more example with me. 60 will go down here, just like in the original. I'm redrawing that basic 30, 60, 90. So across from the 30 is a 1, across from the 60 is a root 3, across from the 90 is a 2. X corresponds to 2. 20 corresponds to root 3. We could cross multiply here. Or if I just multiply both sides by 2, that'll get x by itself. 20 times 2 is 40. All right, so here's another example where we have a radical in the denominator. That square root is not allowed to stay in the denominator, and I do not want a decimal answer. So we're going to practice rationalizing the denominator. I'm going to multiply this by whatever's in the denominator here, whatever's breaking the rule, over itself. Okay, this is me just multiplying by 1. Anything divided by itself is 1, so I am not changing the value of my number at all, but I am going to get that radical out of the denominator. Remember, when you multiply fractions, you can just multiply the numerators and denominators. So 40 times root 3 is 40 root 3. And root 3 times root 3 is 3. And you can come up with that in different ways. As long as you get 3 in the bottom, you're good. Now my answer does not have a radical in the denominator, And I can say that my answer is 40 or root 3 over 3. Let's find y. See, y corresponds to 1 and 20 corresponds to root 3. We're going to have to rationalize the denominator again because y equals 20 over root 3. So if y equals 20 over root 3, then again, I have to multiply by the radical that's in the denominator over itself. 20 times root 3 is just 20 root 3, and root 3 times root 3 is 3. You could think of that as the square root of 9, and the square root of 9 is 3. Or you could think of it as the square root of 3 squared, where the square root and square will actually end up canceling each other out. So your final answer for y is 20 root 3 over 3. All right, I'd like you to try number 9. Redraw your most basic 30, 60, 90 triangle right next to it. Set up your proportions. I think you'll actually see something pretty magical happen in number 9. Go ahead and try that now. So this one actually came out to me really pretty. X was 9 and y is 18. When you set up your proportions, you should have said x over 1 equals 9 root 3 over root 3. But anything divided by itself is 1, so those actually cancel, leaving you with just 9. And if you didn't recognize that, you could type it in your calculator if you wanted to. You would put 9 root 3 in the numerator, root 3 in the denominator, and your calculator would say it's just 9. For y, you'd say y over 2 equals 9 root 3 over root 3. Well, those root 3's would cancel out. And so this is really 9 over 2, or y over 2 equals 9. Multiply both sides by 2, and there's your 18. All right, the next few examples, actually the rest of this is all mixed up. So sometimes the triangle might be a 45, 45, 90. The triangle might be a 30, 60, 90. So you just got to pay attention to what the triangle is in the picture. So that way you draw the correct basic triangle next to it. So number 10, what kind of triangle are you looking at? If you said it's a 45, 45, 90, you're correct. And so next to it, I'm going to draw my most basic 45, 45, 90 as best I can. The legs are in the ratio of 1 to 1, and the hypotenuse is root 2. So now I can say x over 1 equals 28 over root 2. This is one where we're going to have to rationalize the denominator. I'm going to multiply by root 2 over root 2. 28 times root 2 is 28 root 2. And square root of 2 times the square root of 2, well, that's just 2. This can be simplified one more time because 28 can be divided by 2. So 28 over 2 reduces to 14, and that root 2 just has to stay at the top there. So y is 14 root 2. I could go through this whole process again for y if I wanted to, but knowing that 45, 45, 90 is isosceles means x and y here have to be the same. So once I know x, I know what y is going to be also. Number 11, what kind of special right triangle are we looking at here? If you said 30, 60, 90, you are correct. And so we're going to redraw our basic 30, 60, 90 right here next to it. In our basic 30, 60, 90, the short leg is 1, the long leg is root 3, and the hypotenuse is 2. So now I can say x over root 3 equals 16 over 2. You could cross multiply here if you wanted. If you want to simplify this fraction first, you're also welcome to do that. So I'm going to do that. I'm going to say x over root 3 is really, well, 16 over 2 is really 8 over 1. That makes it a little easier to cross multiply, don't you think? If you didn't want to do that and you wanted to say, oh, well, 2x equals 16 root 3 and then divide both sides by 2, you're going to get the same answer. So either way is fine with me. Now y corresponds to 1 and 16 corresponds to 2. If you want to cross multiply, you can. Or if you want to just say, oh, well, y over 1 is y and 16 over 2 is 8. So y equals 8. All right, I've just shown you 2 more examples with a 45, 45, 90 and a 30, 60, 90. Go ahead and try number 12. Decide what kind of triangle it is. Draw your most basic triangle right next to it and set up your proportions so that you can cross multiply and solve for x and y. Try this one now, number 12. Try it now. So you should have recognized this as a 45, 45, 90 triangle. You should have drawn your basic right triangle next to it. Clearly, it doesn't have to be perfect, just so you know what each side corresponds to. And then if you didn't recognize that x and 4 had to be the same since they were legs of this isosceles triangle, maybe you set up the proportion. And if you did, you said, oh, well, x corresponds to 1 and 4 corresponds to y. And then you can see that x really does equal y, or 4. For y was the hypotenuse. It corresponds to the square root of 2, and 4 corresponded to 1. And when you cross multiplied, you get 4 root 2. Hopefully, the more practice problems we do, the easier this is becoming. All right, the rest of these notes are really just practice problems, which I would like you to try on your own. There are a few that I would like to go through just so we can review some of the algebra skills that maybe we need to dust off. So I'm going to skip number 13, 14, and 15 and let you practice these on your own and check your answers on the key on OMHS. Okay, I would really like to jump ahead to number 16 so that we can see some more rationalizing the denominator. Just one more time, rationalizing the denominator question. Hopefully that rationalizing the denominator is becoming easier and easier. Okay, this is a 30, 60, 90. So the short leg is 1, long leg root 3, hypotenuse 2. Ms. Grandy, how do you know that? Oh, I memorized it. So maybe you put it on a flashcard. You put a 30, 60, 90 on the words 30, 60, 90 on one side, and you put the picture on the other. Same with the 45, 45, 90. All right, so let's see. X corresponds to 2, and 6 corresponds to root 3. Now, when you cross multiply, if you do it the long way, and some students get stuck on this cross multiplying thing, so I'm going to show you the long way, then I'm going to show you the shortcut too. If you cross multiply, you end up with x times the square root of 3 equals 12. And then you have to divide both sides by the square root of 3. And so you end up with x equals 12 over root 3. The shortcut way is just to say, oh, just multiply both sides by 2. That gets that x by itself. And 6 times 2 is 12. So either way, whether you do it the first way I did it or you just multiply both sides by 2, we're stuck with x is 12 over root 3. And we need to rationalize the denominator. We do not like a radical in the bottom. So we're going to multiply by a special 1. That special 1 has that ugly denominator in the top and the bottom. Now I can say 12 times root 3 is just 12 root 3. And the square root of 3 times the square root of 3 is 3. One more step, 12 is actually divisible by 3. If your answer had been 12 over 3, you would have been like, oh yeah, it's 4. Well, that root 3 just has to kind of ride along here. So our answer for x is 4 root 3. For y corresponds to 1. I'm going to do it up here at the top. Y corresponds to 1, and 6 corresponds to root 3. Another rationalizing the denominator. So this says that y is 6 over root 3, right? Because y over 1 is just y. Got to multiply by that ugly denominator over itself. Well, 6 times root 3 is just 6 root 3, and root 3 times root 3 is 3. If you had just gotten 6 over 3, you would probably immediately be able to say, oh, that's 2. But don't forget, there's a radical 3 in the numerator, and it just stays there. So this becomes 2 root 3. If you ever want to check your answer, I don't know if I rationalized it correctly, Miss Grandy. How can I check it? What you can do is in your calculator, type 6 divided by root 3 and see what decimal it is. It's a really ugly decimal. But then type 2 root 3 in your calculator, and if you get the exact same ugly decimal, you rationalized it correctly. If you get a different decimal, then you made a mistake somewhere. So if you want to check your answer, check to see, are these two exactly the same in decimal form? And if they are, you did it correctly. And number 7, I want to go over this one just because there is kind of a fun radical property that maybe we don't remember from Algebra 1. In number 17, we have a 45, 45, 90. So I'm going to redraw my 45, 45, 90, where the legs are 1, hypotenuse is root 2. I know whatever x is, y is going to be the same. So I really only have to solve for one variable. Well, I know that x corresponds to 1, and the square root of 10 corresponds to the square root of 2. And you might at this point be trained at this point to say, oh, there's a radical in the denominator. But wait, look, there's a radical in the numerator too. And there's a property that we learned way back in algebra that said that the square root of a number divided by the square root of another number is the same as the square root of their quotient together. So I can actually take my two radicals and combine them into one with division. Okay. That also works for multiplication. So like the square root of a times the square root of b is really the square root of a times b. That works for addition or for multiplication and division. Not so much for addition and subtraction. This rule doesn't work for addition and subtraction, but it does work for division and multiplication. And so here, because x is root 10 over root 2, it's really the square root of 10 over 2. And why do I care about that? 10 is divisible by 2. So this is really the square root of 5. And y is the square root of 5 also. Okay. So I'm going to let you do number 18. Okay, so try number 18 on your own. And we're not going to pause here. I'm going to move on, but you are definitely welcome to try number 18 once the video is finished. Or you could pause now and try it. It's up to you. I do want to go over number 19 and number 21. So let's look at number 19. All right. Now we're starting to get some triangles that are sharing sides. You know, if we had to write a proof, you would probably already be thinking reflexive property, right? Because they're sharing this side right here. Some of you have gotten to know me well enough that you know what I'm going to do right now. Can you guess what I'm going to do? If you said I'm going to redraw these triangles, yeah, you're right. I'm going to redraw them. And I don't redraw triangles because I really like drawing triangles. I redraw them so that I can see what's going on in my picture, just kind of one triangle at a time. If you are not in the habit of redrawing them, may I recommend that you start doing that? I've got two triangles. One is a 45, 45, 90, where the legs are x and y. And the other one is a 30, 60, 90, where this leg is, the short leg is 9, the long leg is not labeled, and the hypotenuse is z. All right, I want to solve for x, y, and z. And the way it is right now, I don't have enough information to do that. So let's figure out what can we do? What can we solve for first? Before today's lesson, you may have said, oh, let's use Pythagorean theorem, right? That works for right triangles. And you're right, it would, except I don't have enough information to use Pythagorean theorem, right? Like if I'm looking at my 30, 60, 90, I'm missing that bottom leg, so I can't find z. And I'm looking at the 45, 45, 90, I'm missing everything. So let's use what we know about special right triangles first. And what I'm going to do is I'm actually going to solve for our missing side that wasn't labeled. I'm going to give it its own variable. How about w? Okay, so that in the picture, that would be here, which means in my 45, 45, 90, that's the hypotenuse. Now let's see here. Let's look at my 30, 60, 90, and I'm going to be able to find z and y, or z and w. 30 would go here, 60 would go here, short leg 1, long leg root 3, hypotenuse 2. I'm going to do the work up here at the top since I'm running out of space. Z corresponds to 2. See why I put the slash through my z's now? Yeah. And 9 corresponds to 1. So when we cross multiply, okay, z is 18. That was easy enough. And now w corresponds to root 3. And 9 corresponds to 1. When I cross multiply, w is 9 root 3. Okay, why did I care about that missing side, really? Well, now I can say this over here is 9 root 3, and now I have enough information to be able to solve for x and y. So I'm going to redraw the most basic 45, 45, 90. I did not give myself enough space. How about this right here? 1, 1 root 2. Whatever x is, y will also be. So I really only have to solve for one or the other. X corresponds to 1, and 9 root 3 corresponds to root 2. Okay. So x over 1 is really just x. And hopefully you looked at this right away. You were thinking, oh, I can't have that radical in the denominator. So I need to multiply by the offending denominator over itself. Okay, so now on the top, we have x equals 9 root 3 times root 2 all over, well, root 2 times root 2 is 2. Remember, when you multiply radicals, you can actually multiply what's in the radical. So this becomes 9 root 6 over 2. And that will be my final answer. It is possible that you would have to continue going. Maybe this 9 over 2 would have reduced. Like if this had actually been an 8, you would have said, oh, well, it's 4 root 6. If your radical simplifies, then you would want to simplify that radical. I don't think they're really going to throw all of that at you at one point, but it might be a good idea to review simplifying radicals if you don't remember how to do that. And I can post a link to what we did at the beginning of the year on OMHS for you also if you want to review that. But our answer here is just 9 root 6 over 2. X and Y are the same. So there you go. Okay, I want to skip down to number 21. 21, here we go. Number 21, we've got 2 triangles again, so let's redraw them. Y, Z, 45, and then we've got X, 30, 60, 90, and a 12. Let's again call that side that they're sharing. Let's give it its own variable name. I'm going to call it W again. All right, let's see here. In the 45, 45, 90, they're all variables. That's not helpful. So let's solve in the 30, 60, 90. So in my 30, 60, 90, the short leg is 1, long leg root 3, hypotenuse 2. So I'm going to do the work at the top again. X corresponds to 1, and 12 corresponds to 2. So X becomes 6, because 12 divided by 2 is 6. W corresponds to root 3, and 12 corresponds to 2. So you could cross multiply, or you could just simplify 12 over 2 as 6, and then multiply both sides by root 3. Either way you do it, you should get 6 root 3. All right, so this is 6 root 3, which means this leg is 6 root 3. Well, now I immediately know why, right? Because this is a 45, 45, 90, and the legs are the same. So y is 6 root 3, that's nice. And now we have to find z. So I'm going to redraw my basic 45, 45, 90 so I can compare the sides. Z corresponds to root 2, and 6 root 3 corresponds to 1. Cross multiply, and you get 6 root 3 times root 2. Well, multiply in your radicals, because the property says if you have 2 radicals multiplied by each other, it's really the square root of those 2 numbers multiplied. So this becomes 6 root 6, and there's your answer. There are a couple other different ways to solve these, and maybe you have been thinking of them and you want to ask, can I solve it a different way? Like if I already know 2 sides of it, can I use the Pythagorean theorem to find the 3rd side? Sure, you could. There's different ways to solve this. I'm showing you kind of the easiest way to do it where you can stay consistent through every single problem. All right, well, look at number 22. You have a 30, 60, 90 big triangle. And it's asking you to find for X, Y, and Z. Okay, I will tell you that even though the big right triangle is 30, 60, 90, because there's a right triangle right here, it means you also have 2 smaller 30, 60, 90s. Go ahead and try number 22. See how you do. Try number 2. You definitely want to redraw these. Try it now. All right, here are my answers. How did you do? Did you get most of them? Did you miss one? See if you can find your error, and I'm going to go through my process. So where's my point? Here we go. I redraw the triangle. So I redrew the small one and the big one, and I called the side that they shared W. Okay, here it is, and it was over here. So then I redrew my basic 30, 60, 90 here, and I said, oh, well, X corresponds to 2, and 7 root 3 corresponds to 1. So you can see my work up here for that. Cross multiply, 2 times 7 is 14. I get 14 root 3. So I said, well, let's find W. Okay, W corresponds to root 3, and 7 root 3 still corresponds to 1. So here's the work for that right here. Okay, so when you cross multiply, you get 7 root 3 times root 3. Well, root 3 times root 3 is the square root of 9, and the square root of 9 is 3. So 7 times 3 is 21. So W is 21. So back down in the picture, I put 21, and then I put 21 over here for that W. And now I have what I need to solve for Z and Y. So I redrew my 30, 60, 90 triangle right above, short leg 1, long leg root 3, hypotenuse 2. So 21, or let's see, I did Y first. Y corresponded to 2, and 21 corresponds to 1. Cross multiply, and there's the 42. Z corresponded to root 3. 21 still corresponds to 1. Cross multiply, and you get 21 root 3. Isn't that fun? I liked that problem. Okay, there's more examples for you to try here. You are definitely welcome to try them. And if you are stuck, please email me, ask me questions. I'm happy to help. And I'll be in office hours Tuesday at noon if you want me to do either of these problems. You just say, hey, Ms. Grandy, can we do number 23 from yesterday's notes? And I'm happy to go over it with you. You are also welcome to check your answers on OMHS. I do recommend doing the practice problems before trying the exit ticket. And then don't forget to do your attendance quiz. The word was given to you in the play posit. So if you missed it, you'll have to go back and look for it. I hope you have a lovely day. And please, again, don't hesitate to ask me questions. I'm happy to help. Have a great day, everyone.